Hey guys, let's talk about energy levels for electrons. Now that we've talked about what the structure of the atom is, there's one little snag that we didn't cover, and that is energy levels. Not every electron is the same. Okay, so let's talk about what that means. It's really not that hard. Okay, so for example, if, once again, let's go back to our two protons, and we'll go to our two neutrons, and I bet you can guess, who is this? This is our helium atom. And remember, if it's a neutral helium atom, it means it has to have the same number of negative charges as it does positive charges. So that means how many electrons do we have to have? I'll give you a second to consider, and the answer is 2. All right. So the way I've been drawing helium is actually fine. We have 2 electrons there, 2 negatives, counteract the 2 positives. This is neutral helium, okay? Now, if we get a little bit more complex and we have more protons, we're going to have more electrons, all right? And that's where the concept of energy levels comes in. Let's take a look at, for example, oxygen, okay? So I'm going to say that we're going to look at oxygen, okay? And that is symbol O on the periodic table. So let's take a look, and oxygen, right, is number 8 on the periodic table. So in this case, I'm going to simplify it to 1, 2, 3, 4, 5, 6, 7, 8. 8 protons. Let's take a look at the neutrons. Let's assume it has the same number of neutrons. 1, 2, 3, 4, 5, 6, 7, and 8. So there's our nucleus for oxygen, okay? And that's quite a bit bigger than helium because it has more. This is a good time to remember this is where all the mass is, okay? So notice that since helium only had 4 particles, 2 protons and 2 neutrons, oxygen has got 16, which is 4 times the mass, okay? So oxygen is a much more massive atom. Now, in order to be a neutral atom, so let's write this down here. We have how many protons? We have 8 protons. How many neutrons? We have 8 neutrons. And in order to be a neutral atom, let's assume it's a neutral atom, we're also going to have 8 electrons, okay? But here's the catch. There are energy levels. In the first energy level of any atom, that's the one that orbits closest into the nucleus, there's only space for 2 electrons. Now obviously I'm not drawing this to scale. So the first energy level has got 2 electrons. Okay, since I have 8 that I have to fill, the rest of them have to go somewhere else. The second energy level is able to hold 8. All right, well, if I have 8 electrons total, 2 of them are in the first energy level. How many do I have for the second energy level? Well, that would be 6. 1, 2, 3, 4, 5, 6. Now, since the second energy level could hold 8, there are 2 spaces open, but since I only have 8 electrons, I'm not going to be able to fill it. All right? So in this case, this is what oxygen would look like. The first energy level can only hold 2. Once I've filled it, I have to move on to the next energy level. Okay, so let's go green and we'll explain. First level equals 2 max. Second level equals 8 max. Okay, and this would be for oxygen. Now, oxygen would have this configuration. In the first energy level, you're going to have 2 electrons, and in the second energy level, you would have 6 electrons. All right, let's do an example. Okay, so what about this example? 1, 2, 3, 4, 5, 6. And just for fun, we'll do the neutrons. 1, 2, 3, 4, 5, 6. So this is an atom that has 6 protons. Now let's assume that we're talking about a neutral atom. So let's go back here. It's got 6 protons, and we also gave it 6 neutrons. Since it has 6 protons, can you guess which element it is? And we're going to make it a neutral atom, so it has to have 6 Oops. Electrons. Okay? If you guessed carbon, you're correct. This is carbon. Okay? And it's actually carbon with 6 neutrons and 6 protons, so it's actually just good old carbon-12. All right? So in this case, I've got the first energy level, and how many electrons can the first energy level hold? If you answered 2, you're correct. So here's the first 2. Now that means I have how many more electrons left to fill? I've got 4. So in my second energy level, I can put 4 electrons. And for right now, it doesn't matter where you put them. You can just distribute them around. I can put one there, one there, one there, and one there. Okay. So in this case, carbon would have 2 electrons in the first energy level and 4 electrons in the second energy level. Okay. Now, this also applies to the third energy level. All right. So the 2 energy levels of difference is, in this case, first level to max. The second level can hold 8 max, and the third level can also hold 8 max. Okay, so what this means is that you're looking at the first 3 energy levels, okay, and these are the electrons that they can hold. What does this look like in terms of a diagram? Okay, let's look at it on the next page. If I were to start filling them up, and for purposes, I'm just going to do this for the nucleus for right now. We're just going to save some protons and some neutrons, okay? So we're going to have protons and neutrons in the nucleus. I'm not going to count up how many they are, okay? Now we're going to go to the electrons. Energy level number 1, you can put 2. Energy level number 2, 1, 2, 3, 4, 5, 6, 7, and 8. That's energy level number 2. That's full now. If I have any more electrons, I have to go to the third level. And the third level also has room for 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is what it looks like. Okay, we're not going to go beyond the third energy level. So, once again, first equals 2, second equals 8, and third also equals 8. We're not going to go beyond that because it gets a little strange, and for right now, this is all you need to know. This gets us up to almost the first 20 elements or so, which is just fine, okay? And so these are the rules you follow. You simply fill them one level at a time. You fill the first level first, the second level second, and the third level third, all right? And again, we're assuming this is for neutral atoms right now, but this also applies to ions, okay? So let's do one more example. How would you draw an ion? And this is the one we want. We want oxygen with a -2 charge. Oh my goodness. How are we going to do that? For this purpose, I'm going to go ahead purple, and we're going to put some some protons in the nucleus, and we're going to put some neutrons in the nucleus, all right? And remember, oxygen, if you're oxygen, you have to have 8 protons. And we're going to assume, not that it matters, that we have 8 neutrons. But since we have a -2 charge, it appears that we're going to have more electrons than we do protons. So, if we have a -2 charge, how many electrons would we have? Anybody? If you said 10, you're absolutely correct, because that means you have 2 more negatives than you do positives, which means you have a -2 charge. So we have 10 electrons to fill. Let's do it. First energy level, 1, 2. Second energy level, how many more do I have? I have to put 8 more. 1, 2, 3, 4, 5, 6, 7, 8. How nice. It nice and neatly fills the second energy level. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, okay, 10 electrons filling up the first two energy levels. So this is an oxygen ion, okay, with a charge of -2 because there are 2 more electrons than protons. Okay?